Hi everyone. So sorry I'm not with you today, but I should be back tomorrow. I'm going to do the lesson with you nonetheless. And so we're going to start by checking our homework from lesson 5-7. So let's see how that went with our lesson on transformations. Take a second to open up your homework now and split screen if you need to. And just make sure that your answers match mine. This might be a good time to just pause the video, really take a look at not only the coordinates that are listed, but also the new image of each of the figures. So pause now, take a second to check, and then if you do have any questions, feel free to ask me tomorrow, or you could always send me an email to let me know something doesn't make sense. But hopefully you remembered how to do each of these transformations from Thursday. Okay. The next thing we're going to do is take a look at a warm-up. This is under today's note sheet, so you can download this right from the home screen today, Tuesday, February 22nd. And we'll start with our target. I can apply congruence to solve for missing measurements in congruent polygons. And we're also going to start with a warm-up. In this warm-up, it says to solve for x and the measure of angle ABC in the polygon shown below. I would say that this is a bit of a challenge warm-up. When we look at this figure, we could figure out what type of figure it is, certainly by counting the sides, and we could actually see that it's a six-sided figure, so it is a hexagon. Clearly, it is not regular, however, as we can see many different angles and side lengths. When I want to find measure ABC, I'm going to start by figuring out where that angle actually is. So let's identify it in the figure. So the angle ABC, I would want to trace from A to B to C. And I see that that's this entire angle here. So it includes 2x and 12x. The problem is we don't know what x is. So the next task in this problem is going to be to figure out what the measure of x is. Now I can see there's lots of different x's all around this figure, but as I try to focus in, I don't see any parallel lines or anything like that that would help me relationship-wise there. But I do notice a right angle in the center, and that right angle is very helpful because that is actually part of a triangle. So I'm now going to focus in on just that triangle, and I can see that I know 3 measures of that triangle, at least in relation to x, because I know that the right angle is 90 degrees. So if I focus on my knowledge of triangles, I could set this up by taking the 3 angles 3x, 12x, and 90 and adding them up and setting it equal to 180. Now my goal here is to be able to solve for x, and this should enable me to do it. So I'm going to go ahead and add up my 2 x terms, and I get 15x. That was just combining like terms. And the next thing I'm going to do is I'm going to subtract by 90, and I end up with 15x equals 90. So now I'm going to divide both sides by 15, and that tells me that x is 6. Now that's a very important part of the problem, but I'm not finished because now I need to go back and remember my goal was to find the measure of angle ABC. So since the measure of angle ABC is comprised of 2x plus 12x, what I'm now going to do is substitute x in as 6. Actually, an even easier way to do this would have been, I'm going to go back a step here. Instead of putting 6 in for both of those, certainly you could do that. But when you notice that these are both x terms, you could actually combine them to make 14x right now. And then that would allow me to just do 14 times 6 and get 84 degrees. So the measure of angle ABC equals 84 degrees. All right. Next up, we're going to jump right into our congruent lesson. So we've been using the word congruence for quite a while now, and hopefully you remember that that just means that they contain they have the same size and the same shape, which means that all of their pieces are congruent. So some important things to note about congruency. Their corresponding angles are all going to be congruent. We've seen that word corresponding before. Basically, it just means that it's in the same spot respectively. Then it says their corresponding sides are congruent. So I also want to look at the sides that match up. Now, something that's very interesting is the placement of the markings is very crucial in us determining congruence. So when I see, and we've talked about this before, but when we have just one marking, that matches with the side with one mark. When we have an angle with 3 markings, that matches with the angle that has 3 marks. So you're always looking for the number of marks in the angle and then the little hash marks on the segments as well. So when it says angle D corresponds with, we would want to list the angle that is in the same spot. So I'm going to find the angle that just simply has the 1 marking, and I'll erase these previous marks. That, of course, is K. So angle D corresponds with angle K. Then we next can look for the one with 2 markings. That's clearly going to be J. So angle E corresponds with angle J, and angle F corresponds with angle I. On the other hand, we can also find segments that are congruent. And this time you have to be a little bit more careful about the order. So whenever I go to label the matching segment to DE, the one that's in the corresponding position, especially in the instance that the angles are different, notice that, which is the true in this case based on the way that it's marked, DE, we go from 1 marking to 2. So I would now want to find the 1 mark angle, which is K, and go to the one with 2, which is J. So in that order, I list my segment KJ and just put my segment marking on top. For EF, I see that it goes from 2 to 3. So I now go to the other figure, and that goes from J to I. So this next one would be segment JI. And then DF actually goes from 1 to 3. So now we would want to go from 1 to 3, which would be segment KI. The next thing that we could do is write a congruent statement that would match the entire triangle. And so we want to make sure that we do it in a correct order. So it doesn't really matter what you start with necessarily. So let's do triangle DEF. Then we use the congruent symbol, and we would match it up with triangle. Now let's see, we went from 1 to 2 and 2 to 3. So we would go 1 to 2 and 2 to 3 on the other figure, and it would be triangle KJI. And what we just wrote there is a congruent statement. The congruent statement gives us a lot of meaning. We'll see that later on in the lesson. So next, we have an example, and we're going to use this example to finish the congruent statements. So let's start by figuring out the angle that is corresponding and therefore congruent to angle U. So angle U matches with the other 1 marking, which would be angle M. Angle V had 2 marks at its angle, so it matches with angle A. Angle W has 3, so it matches with angle T. And angle X has 4, which matches with angle H. Next, I can look at my segments. So UV 1 to 2 would match with M to A. Be careful because we want to go in the correct order. Then VW goes from 2 to 3. So that matches with AT. And then WX goes from 3 to 4, which would match with TH. Finally, XU goes from 4 back to 1, which would match with HM. So the order of all of those were very important for the segments because we are picking the same spot that the previous figure started at. Next, when we write our total congruent statement, we could say that this is quad U, V, W, X, And since we started at the 1 and went to 2, then 3, then 4, we would start at 1 for this second figure, which is M. So we'd say quad M, A, T, H. And there's a little math humor for you there. When you're matching up, the congruent statement has to match up with the corresponding pieces in the same order. That's the key. Okay, next. We have a congruent statement that we're going to write for these two triangles. So we have triangle, and you could start at any angle, by the way. It doesn't always have to be alphabetical, though generally we do start alphabetically just to make things easier. So if I go from 40 to 90 to 50, so if I'm starting by listing those angles, I would write triangle A, B, C, and then the congruent symbol, congruent to triangle D, E, F. Because D was 40, also 1, E was 92, and C was 50, angle 3. Our next figure actually has a couple of options. If we wanted to go out alphabetically for the first one and do A to B, B to C, C to D, then we could simply say quad A, B, C, D is congruent to, didn't leave a whole lot of space here, quad, and then we want to make sure we started at an angle that's 65. So you could do N to M, M to T, T to R. So that would be quad N, M, T, R. And then you actually also could have started at T. So if we kind of erase these marks and picture it, if this had been a full rotation, then you could actually do T to R, R to N, N to M as well. So just so you know, there's sometimes more than one correct answer when matching these up. Okay, in this next figure, I love this one because we get to do some algebra within geometry again. We're going to use our congruent statement to help us here. So when you take a look at this, it says quad VWXY is congruent to quad JKLM. And we're asked to find the value of A, B, and C. So let's start by identifying where little a is in the figure. So sometimes, if you've ever seen the joke where it says in the figure something like this, and it says find X, and the student says something like, here it is. We've probably all seen those little jokes. That's funny, but that actually is what we're doing here. We are literally having to find it in this very first step. So let's start by finding little a and see which piece of the figure it's at. So when I start, I can see that little a is located at segment WX. So that's really important here. So I'm going to start by writing segment WX, and then I'm going to look at my congruent statement. When I see in my congruent statement that WX is the second and third letter, I know that that matches with my second and third letter here, which was segment KL. So since WX is congruent to segment KL in the figure, I know that my measure for WX, which was A plus 8, must be the same measure, so equivalent to the measure for segment KL, which was 24. So now, all I have to do is solve by using inverse operations, so I'll subtract 8 and find that little a is 16. Okay, next, let's go ahead and look for little b. So we'll start and see that little b is at segment LM. So LM in the figure was third and fourth, which matches with the third and fourth letter over here, which was XY. So LM's measure was 4 times B minus 3, and that's going to be equal to segment XY, which is 30. So the next thing I'm going to do to solve is I'm going to distribute this 4 through. Remember the distributive property, we can do 4 times b to get 4b. The minus sign comes down, and 4 times 3 is 12. Then I have a two-step equation to solve, so I'm going to start by adding 12 to both sides, and I find that 4b is 42. Next, I'm going to divide both sides by 4, and I find that b is 10 and a half, so 10.5. We weren't given any units here, so saying 10.5 is fine, or you could add u in if you wanted to. All right, next, we're going to look for little c. So when I look in my figure, I see little c is actually at an angle. There's a couple hints for that. First of all, I see that it's an interior marking. It's inside the figure. And I can see that it has a degree measure. So it's at angle J. So now I go back up to my statement and I see that angle J is first, which means it matches with angle V. So angle V was over here, 85. So I would say angle J is congruent to angle V. And then I see that J's measure is 5C and angle V's measure is 85. So my only step to solve is to divide both sides by 5. And then I get an answer of C equals 17. Okay. In this next figure, we'll go ahead and read through it. It says the two pentagons are congruent. Find the values of t, y, x, and z. But there's actually a big piece to this problem that is missing that we need to have before we can continue. So I'm going to add it in, and you need to do the same on your note sheet. So let's add in our congruent statement. So the congruent statement is so crucial to making the problem. So we're going to write in pentagon, F, E, D, C, G, notice not in alphabetical order, it won't always be, is congruent to pentagon, A, Z, M, S, R. And we're going to use that to solve for the different variables. So let's begin with the first one listed, which is little t. So we're going to begin just like the previous problem by searching for little t to begin with. And we notice that little t is up here at angle S, right there. So it's definitely an angle, has a degree measure. So if I go to my statement, S was the fourth letter, so it matches with angle C. So when I'm solving for t, I'm starting with angle S is congruent to angle C. Since S measured 2t, that's going to be equal to the measure for angle C, which is 120. So I divide by 2, and I find that t is 60. Now you don't actually have to put a degree measure there since there was already a degree with the total angle, but if you do, I would never mark that wrong. All right, next we're going to look for little y. So for little y, we can start by seeing that it's located at this segment right here, which is FG. Notice that FG is the first and last letter. So FG, segment FG, is congruent to segment AR. FG measured y minus 3, so that'll equal AR's measure right here, which is 10. So I would just add 3 onto both sides, and I end up finding that y is 13. Next, we have little x. So let's go to our figure and find little x. This is interesting. You'll notice that there are actually 2 of them. So we could start at either one. Notice that it's at segment FE, which is first and second here. So that matches with AZ, and segment AZ also has an X in it. Now, at first glance, you might be thinking, oh no, we're not going to be able to solve that. But remember, as long as it is in terms of the same variable, then it's doable. So FE, segment FE is congruent to segment AZ. FE equaled 13 times Z, so that's going to be equal to 3X. I'm sorry, I didn't mean to put Z, I meant to put X. Fix that. 3x plus 2. So now we're going to go ahead and get the x's together. Now, we haven't done a ton with variables on both sides, but we just need to get the variables together, and we can use inverse operations to do that. So I will subtract 3x, and I end up getting 10x is equal to 2. So then the next thing that I need to do is divide both sides by 10. And I would get an answer of a simplified fraction that's 1/5, or you could say 0.2. So either one would be fine. And our last one, little z. So let's find little z in the problem. We can see that it's at angle A, which is our first letter. So that matches with our first letter over here, which is angle F. So little z is at angle A, and angle A is congruent to angle F. So A was z over 2. Remember, that's z divided by 2. And F, we can clearly see here, is 1/50. So to solve, to undo the division, we have to multiply both sides by 2 to isolate z, and we get 300. All right, guys, for the rest of class, you can feel free to do your quick check and begin your homework, and just email me if you have any questions, but I hope this lesson was pretty easy for you to follow. We'll review a little bit tomorrow in class as well. Thanks, guys. Hope you're having a great day, and I'll see you tomorrow.